The nuclear fission equation you are seeing on the board simply means that when the nucleus of uranium-35, this is the nucleus, okay? When the nucleus of uranium-35, 235 is bombarded with slow-moving neutron. I repeat, when the nucleus, this is a heavy nucleus of uranium-235 is bombarded with neutron, a slow-moving neutron. It's going to split or disintegrate or break into other elements, which we are going to see. We are going to see somewhere, it's going to be something here, and then somewhere, another one here, or small amount of energy, okay, so to say. Now, the question is, how is it going to be? Remember that what we're trying to do is to bombard, the nucleus, the heavy nucleus of uranium-235 elements. And by the time we do that, using a slow-moving neutron, it's going to break into or split into. That's the meaning of fission. Fission means break into or split into two or more elements with the release of huge amount of energy, right? So if that happens, what do we have as the products? Okay? The products X, Y, and Q represent something. Q represent the energy released. So that's what we are concerned here. So let's see how that happens. If we have understood this, that by bombarding the heavy nucleus of a uranium element 235, we're going to have products such as X, Y, and then the release of energy represented with letter Q. Let's see how it happens. So with this is the slow-moving neutron used to bombard uranium-235 elements, 9 atomic number 92, all right? So it's going to fission into beryllium-141, atomic number 56, all right? Okay, that's the first split. It's going to split into this. The next one is going to be krypton, Kr, and this is 36, atomic number 36, and then we have 92, okay, 92 plus release of neutron again. Come on, an amount of energy, Q. That's what it means. Okay, can you see it now? Look at it. Where Q, the Q over there, that Q you're seeing or you're looking at represents energy released. Represent energy. So take note of that. So what happens is, look at the mass number. There is a mass defect whereby the products, just look at it. And when that happens, there is a release of what? Energy. So bombarding the nucleus, the heavy nucleus of a uranium elements with a slow-moving neutron fissions into beryllium-141 mass number and 56 atomic number, krypton 92, and then 36 atomic number with all the rest you are looking at. So that's what happens. And we can explain further. We can explain further this by the time we understand the mass defects. Okay, mass defects, which I will take time to explain in my next class. And don't forget that Albert Einstein's equation plays a vital or a crucial role in this. Don't forget that. Albert Einstein equation that has that E is equal to mc squared. This plays a crucial role in all this nuclear energy stuff. So I'm going to stop at this point and thank you for watching. Don't forget, share with your friends, put on the bell button for constant notification. Things like this will always come your way.